Thank you so much. And let's get rid of that. Very good. So great to be back with you folks this evening again to tell some bug stories and share some ideas with you. I'm looking very much forward till the time we can actually do some face-to-face. That'll be even more fun because I can bring creepy bugs with me to these presentations. But it is nice to be able to get back a little bit more. I've done a couple face-to-faces, which recently in the past couple weeks, and I think we can look forward to a 2022 where we really have the opportunity to meet each other a little bit and share some more interest that we have in the natural history of these fascinating creatures. So with that, I'm going to bring up the share screen, and hopefully someone can give me a thumbs up if they see a very jolly looking spotted lanternfly. Okay, very good. All right, with that, let's get going. So, as Bronwood said, you can always contact me. This is my email, mraupp@umd.edu, and I hope that many of you have been following me at my Bug of the Week blog. It's on any browser, simply Bug of the Week. It'll be the first one that pops up. I've been doing this now for about 16 years. There are several hundred episodes in there, and it links to my YouTube channel, YouTube Bug of the Week. So you can learn about the natural history and ecology of some of the common bugs in our area. And usually I manage to get down to Central or South America for a little bit, and we'll learn some stories about creatures that live in cloud forests and places like that as well. But tonight we're kind of bring it on home and talk a little bit about the spotted lanternfly. Now, as part of my responsibility at University of Maryland, I help landscapers, urban foresters, city planners, and the general public try to find ways to make our urban forests more sustainable. And to me, there are 6 major threats to the sustainability of the urban forests that surround us that are in play right now on all issues we have to address. One of the most important we've talked about before, of course, is the lack of plant and animal biodiversity. Tonight, we're going to delve into the realm of the importation of exotic invasive species, but perhaps some other time we can talk about what it means when we substitute non-native plants for native plants, the effects of climate change on plants, pests, and natural enemies, how impervious surface, the #1 enemy of plants in the built environment, affects biodiversity. And finally, I often speak to my practitioners, arborists, and landscapers about how anthropogenic inputs, things like fertilizers and pesticides, can disrupt ecological communities and threaten the sustainability of our urban forests. Now, invasive species. This one could be familiar to most of you because I bet you've had it in your house, the brown marmorated stink bug. But there's been a host of these things. I was originally hired to work on this one right here, the gypsy moth, back in the early 1980s to help people understand what it was and what was going to happen. But during that time, I've worked with the Asian longhorn beetle, euonymus scale, viburnum leaf beetle, Japanese beetles, emerald ash borer, but the new kid on the block, spotted lanternfly. Now, this question is the rate of importation of these exotic species increasing? How many say yes? How many say no? How many say they don't know? I didn't get everybody yet, so I'm guessing the rest of you, how many say they don't care whether it's increasing or decreasing? Well, I think we all have to care, but I was charged with giving a talk over in the UK, and I thought I knew the answer. I thought it was simple. Increasing, right? Not really. If we look at the cumulative number of pest detections plotted against time, you can see the big change came right here. So in the early 1600s, the first pest was the apple maggot, I believe, that came in when Johnny Appleseed brought his apples to this country. But for more than a century, that rate, in other words, the change over time, has been relatively static. The big change came right here at this inflection point, was just about in the 1880s, 1890s. That's when it kind of went hockey stick. But if you'll notice, for the past more than 100 years, the rate, in other words, this line right here, change through time, has been static. It isn't to say there aren't more invasive species coming all the time. It simply says that the rate has remained the same. Now, what was the major development right here that caused us to go from this to that? And you can unmute if you think you have the answer. I'd be glad to hear what you think caused this inflection point. You don't have to be bashful, because there's no penalty for wrong answers or guesses except humiliation among your colleagues here. So please feel free to do so. Any guesses?
And you can put it in the chat box, or you can say it out loud. So Robin just.
I don't have the chat open right now. Maybe I can open that up.
So we
Industrial Revolution.
Very good. It was the Industrial Revolution, right? Trains, yep, which issued in an era when it no longer took 2 months to sail from Europe to Indonesia or North America. You could now hop in a steamship that was powered by an engine and sail across the sea. So it opened up a period of exploration and a period of importation. When we traveled throughout the world to bring new crops to the United States, ornamental plants, and of course, as we increase the plant biodiversity, the higher trophic levels, the things that feed on plants, unfortunately come along with them. So very good answer, gang. I think you've got that one. Now, who are the invaders? And again, I'm going to reference this primarily to forest systems, urban forests. If we scan down the different orders of insects, you can see that the clear-cut winners are these guys right here. In terms of number and species, it is the Hemiptera, the true bugs, that outpace all the other orders of insects in terms of who has arrived in this country. Okay, so it's these Hemiptera. Again, we have a lot of beetles that have come in, a lot of moths and butterflies have come in, but the real winners right here are the Hemiptera. Now, what are lanternflies and what are Hemiptera? Well, Hemiptera are what we call the true bugs. They're characterized, hemi meaning half, ptera meaning wing. So these are the half-wing bugs. Bugs with insects with half of the wing membranous and half of the wing leathery, hence the name Hemiptera. They can be further subdivided into 3 suborders, the Heteroptera, which include things like our friend, the pest, the brown marmorated stink bug, or highly beneficial insects like this assassin bug, which many of you know is the wheel bug. Now, that's not like Elmer Fudd saying the real bug. It is the wheel bug because it has this very strange wheel on its back. The purpose of this is known only to Mother Nature and the wheel bug. Heteroptera means different wing. So beneath the outer wings that are half membranous, half leathery, there are a pair of wings that are all membranous. Hemiptera, Heteroptera, the true bugs. They have incomplete metamorphosis, meaning that the adults lay eggs, those eggs hatch into nymphs, and then those nymphs molt several times before becoming adults. These can be divided the Hemiptera into another group called the Echinoranca. That term refers to the orientation or the location of its mouth parts. That includes common pests, common insects like leaf hoppers, tree hoppers, plant hoppers, frog hoppers, and our friends, the fulgurids, things like lanternflies. And finally, a really nasty bunch of insects called the Sternoranca, which include aphids, adelgids, whiteflies, psyllids, scale insects. Some of the most important pests on the planet belong to this particular group of the Hemiptera. As I said, they have gradual metamorphosis. Eggs hatch into nymphs, nymphs molt into adults. So they're a little bit different than the insects with complete metamorphosis, those that adults lay eggs, the eggs hatch into larvae. Larvae will transform into the pupa before becoming adults. And as I said, they have sucking mouth parts. So what do they do with those sucking mouth parts? Well, many of these feed on vascular tissues. Some will simply pierce cells and feed on mesophyll cells, epidermal cells. However, many of the Hemiptera dig deeper into the plant and tap in to the vascular tissues, into vascular bundles. Now, in the vascular bundles, there are two different types of tissues. One, of course, is the xylem. The xylem is responsible for obtaining water and minerals from the soil and transporting those key elements up to the leaves of the plant where photosynthesis happens, the magic. The products of photosynthesis are then transferred back down and throughout the plant through the phloem tissue. It turns out that our friend, the spotted lanternfly, and many other of the Hemiptera feed on that nutrient-rich phloem tissue in the vascular bundle. They take their beak. It has stylets. In these stylets are two channels. There is a salivary channel that they use to inject saliva into the plant to liquefy plant tissues. Once those tissues are liquefied, they turn on a little hydraulic pump in their head and they suck up the liquefied food into their head through the food channel, essentially. Okay, so there are two channels in this beak that pierces the plant. What do lanternflies look like? Well, many of our tropical lanternflies, where they reach the greatest diversity, have these very, very unusual structures on their head. I believe there were tales probably that these structures actually glowed in the dark or something like that, or were thought to be lanterns. Well, I've spent a lot of time with these guys in the jungle, and frankly, I've never seen one light up. There are some pretty interesting characters. This is one of my favorites. This is called the peanut head lanternfly. But hey, guess what? I think that looks like a crocodile or a reptile. Look at this, two eyes, this big toothy grin. Can you imagine a bird sneaking up on that thing and then that thing turns around and all of a sudden it's looking at an alligator face? I'm leaving that alone, right? So a pretty clever disguise. But what we'll spend our time with today is this beautiful insect known as the spotted lanternfly. Okay, these kind of 20 wings with these black spots, these little black lines of dots. The underwings are beautiful orange and black spotted, black and white stripes. This is clearly an aposematic insect, okay, flashing its distastefulness to any predator that might want to eat it. We're going to walk through a little story. Again, this is a video from one of my episodes of Bug of the Week. So I'm going to go ahead and just run this for you so you can see what some of these rascals look like and what we have in store throughout the state of Maryland very soon. Let's have a quick look at the life cycle of spotted lanternfly. Right now, we can find hundreds of them resting and feeding on the bark of trees. Soon they will lay their eggs, which are covered in white wax. But by late winter and early spring, that wax will have worn off or turned a tawny brown color, matching the bark of the tree. In May and June, those eggs will hatch, and the small lanternfly nymphs will be jet black in color with white spots on their body. Here you see the fourth and final juvenile stage of spotted lanternflies, scarlet bodies with black patches and white spots, side by side with the third stage, which has the black body and white spots. In the field now, we can see the bark of trees and underlying vegetation covered with honeydew, which encourages the growth of black sooty mold. Large colonies of adults will be seen feeding and laying eggs on the bark of the tree until a killing frost puts an end to this generation. Okay, gang. I hope everybody was able to hear the audio track on that and follow. Thumbs up. Excellent, good. All right, so that gives you a little bit of an overview. Let's take, whoops, let's get rid of that now, move on. There we go. So a different graphic. Right now, I ran that story back probably in October. So right now, here we are with eggs. Eggs will be on the trees from now until about June when they start to hatch. Then we'll have the first instar nymphs, again, black with those white spots, second instars, third instars, June and July. And finally, July through September, we'll have that spectacular looking bright red nymph with the black and white patches on its back. They will then molt into the adult stage July through December, and they're pretty much finished now. We've had the killing frost, and between September and December, they've been laying eggs on plants, but not only on plants, and this is one of the big problems. They also lay their eggs on many other substrates. They will lay their eggs on rocks. They will lay their eggs on picnic tables. They will lay their eggs on stone walls. They will lay their eggs on semis that are parked near rest stops in the state of Pennsylvania. And this is really how these guys are dispersing right now. We'll talk about more of that in just a few moments. Now, how do phloem feeders damage plants? And this isn't just for lanternflies. I often speak about aphids and whiteflies and other phloem feeders, scale insects. Basically, they're damaging the tissue and removing the products of photosynthesis. This will result in discoloration of the plant leaves, yellowing, premature leaf drop, distortion. In the case of aphids, they will cup leaves, die back. When we have scale insects that are very dense on plants, we'll actually see branches die back. Products that they produce include both wax, but also honeydew. And honeydew is going to be the substrate for a non-pathogenic fungus called sooty mold. This is going to disfigure plants. The honeydew will also attract ants and other stinging insects. So let's have a little bit of a look at this. Again, these are some of the other phloem feeders that you might be familiar with. Rascals like aphids, like whiteflies. If you live out west, psyllid insects, areococcids, mealybugs, soft scales, margarodids. These are all sucking insects that are phloem feeders and produce honeydew. This is spotted lanternfly. These are pictures from Pennsylvania. This is not a furry tree. This is a tree, a maple tree, I think, with literally thousands of spotted lanternflies lining the bark of the tree. And this is what we are going to see here in Maryland. We're already seeing this in certain places. They're going to produce vast amounts of honeydew that's going to drip down and rain down beneath the tree. The real issue here, the real problem, we'll talk about economics a little bit later, is what they're going to do to vineyards. It's really the grape growers at present that are under the greatest risk because densities will become so high in vineyards, they will actually kill these vines. And in Pennsylvania, to my knowledge, they've already extirpated 2 vineyards despite repeated attempts to try to control these with fairly potent insecticides. They'll also get in apples, and as you might guess, they're not going to kill apple trees, but the honeydew that rains down on the apple is going to reduce the value of that apple. I was able to obtain one picture. This one is from South Korea, shared with me by my colleague Tracy Lesky. These trees have been heavily infested with spotted lanternflies for many, many years, and we see dieback in the canopy. But here in the States, we really don't have good data yet, but it's our belief that these are not going to be killers of trees or other woody plants. Although I bumped into some arborists in central Pennsylvania at a meeting recently, and they said that after several repeated years of high densities, that some of the tree of heaven, which is one of their favorite host trees, are showing decline. So again, backing it out, this is going to be the big problem. It's going to be a huge problem in vineyards. The other interesting piece of this puzzle is this honeydew business. I'm going to run another video for you now. This one I shot up in Rock State Park, which I'm sure is familiar to many of you. So let's learn a little bit about spotted lanternfly honeydew. Spotted lanternflies feed on a sugar-rich plant tissue known as phloem to gain sufficient nutrients to support growth, development, and egg production. They remove vast quantities of phloem from the plant and excrete the excess as a sugary solution known as honeydew. When many lanternflies are present, honeydew will drip down the tree and accumulate in pools at the base of the tree. Watch as these feeding lanternflies squirt honeydew from their rear ends. If you stand underneath these trees, hey, you're going to get a lanternfly shower. A lanternfly shower. Like Creedence Clearwater Revival said, it will rain on a sunny day. In fact, I was working with a film crew over in Northern Virginia. I think it was an NBC crew. And it was a bright sunny day. We were out underneath the lanternfly tree, taking pictures and telling bug stories. And the reporter looked up and said, "Why is it raining on a sunny day?" And I said, well, you know, it's simply the golden shower of the lanternfly. So lanternflies are going to create a bit of a nuisance when they create these large amounts of honeydew. Now, here's the other piece of the puzzle. Spotted lanternflies. I'll run one more video for you here. The sweet, sticky honeydew that accumulates on the trees and ground can create a real nuisance. It attracts a great variety of stinging insects like yellow jackets, paper wasps, and hornets like this big European hornet. Many honeybees also forage on the honeydew. Could this be an important source of nutrients for honeybees late in the season? Oh, could it be? I'm sure those of you who have followed the plight of the honeybee know that one of the real problems with our honeybees is late season nectar sources. As I watched the lanternflies at several locations, I found honeybees coming to forage, and this was in October and November, on the sweet honeydew produced by the lanternfly. So, you know, with all the bad, there's often some kind of good as well. And I just wonder how important this might be as a food resource for some of our honeybees. So maybe there's a little bit of good in this otherwise surprisingly bad situation. The sweet. Okay. Now, some of you may have seen me eating cicadas and eating other insects. Should we give those a try? Well, it turns out that in Chinese medicine, spotted lanternflies have been used as a topical application to reduce swelling and inflammation. They're considered not food. So I think my recommendation is not to eat lanternflies. In fact, we've gotten reports of dogs, animals, dogs in particular, eating spotted lanternflies and becoming sick. So, you know, it's okay if Rover snacks on a few cicadas probably, but steer them clear of spotted lanternflies if they should become interested in those. How did the spotted lanternfly arrive? Well, I think in the news, they've really made a point of how many of our goods are shipped from foreign countries and arrive in these ports or not every day, right? There are literally thousands of container ships sailing across the seas. And the inside big containers, of course, are what? Little containers. And inside little containers are what? Products. We believe that spotted lanternfly was introduced into Berks County, Pennsylvania, and Frederick County, Virginia, on a shipment of stone products that came from China. If you look carefully on this stone product, you see spotted lanternfly egg masses. They're pretty easy to miss. They look like it might be some kind of debris or moss, but this is what the egg mass is. We're pretty sure they came in as egg masses. Again, this is the way that many of our new pests are coming. People will ask, they've asked, why Berks County, Pennsylvania? What's up with that? Well, the curious thing here is that Berks County was also the location here in Allentown where the brown marmorated stink bug first showed up. So what is it? Well, I have family that lives right about here in rural New Jersey. So when I go to visit, I hop up from York, I go on over here up to Lancaster, Reading, Route 78. The eastern terminus of Route 78 is Port of Elizabeth. So my guess is these things are coming in on ships. They're being loaded on semis. They're being driven to distribution centers out here in Pennsylvania. There's a lot of warehouses and shipping points here. And look at your interstate system. You've got north, south, east, and west. You've got rail lines going through this area, the perfect transportation site for spotted lanternflies to move around or invasive pests. Where are they native to? They're native to China. They're invasive in Korea, Taiwan, and Vietnam. And now in Japan, I believe. What was the predicted range? Using climatic data, primarily from Asia, they predicted that spotted lanternfly would occupy areas here and a narrow band throughout this part of the country. Now, the good news here from a phenological standpoint is that spotted lanternflies are univoltine. That means one generation a year, and it takes a relatively long time for them to develop. They think in colder parts of the country, including the Allegheny Plateau, it's simply going to be too cold. The growing season is not going to be long enough for them to complete a generation. That was the early thinking. The later thinking was this. With more data now coming in from the United States, the most recent projection I've seen is a distribution that includes parts of the Midwest, all the way up to temperate areas that are being moderated by the Great Lakes, coastal areas. But the bad news, gang, look at this. California, Washington, and Oregon, some of the most economically important grape growing regions in the country. Again, you've got your New York grape growing regions here. You've got grape growing regions here in Virginia, of course, West Virginia, Ohio. So not looking good in terms of projected distributions. First records were in Berks County in 2014. We thought it probably came in 2012. It took a couple years before it was discovered. Delaware 2017, New Jersey 2018, New York, isolated detections up as far north as Albany, Virginia, an established breeding population. Established means they're breeding and reproducing. Some of these others were simply detections of one individual. an egg mass or something like that. Maryland, it came into Maryland and Cecil in 2018. Here's the current map. As of about a month ago, we are now in Indiana, Ohio, Pennsylvania, New York, West Virginia, Maryland, Delaware, New Jersey, New York, Connecticut, and Massachusetts with breeding established populations. We've had isolated individuals travel as far as 500 miles to Henderson County, North Carolina. All these, you can't really see them well in this map, but there are dozens and dozens of these little purple dots scattered throughout. These are where isolated individuals have been found, but I've got to believe that this genie is now out of the bottle, and it's only a matter of time before we'll see a ever increasing wider distribution of spotted lanternfly. Washington, Frederick, Montgomery, Howard, Carroll, Baltimore, Baltimore City, Hartford, Cecil, Kent, and Anne Arundel. The district is surrounded, Prince William, Montgomery, Anne Arundel. So it's only a matter of time before we see spotted lanternflies on the mall, I think. This year has been a big year for COVID. It was a giant year for spotted lanternfly. Here in Maryland, we went from 2 counties to 9 counties in a single year. Virginia, 2 counties to about 6 or 7 counties. So we're now seeing a very rapid distribution. This is very typical. This is exactly the same way that brown marmorated stink bite dynamics went. So we're into that phase now where we're going to see a much more rapid spread of spotted lanternfly throughout the DMV. What can we do to stop this spread? Okay, well, there have been quarantines erected in a variety of states. These red areas you see are quarantine counties where you're not supposed to be transporting materials through these landscapes. That means firewood. It means lawn furniture. It means any place where spotted lanternflies could have laid their eggs. It's very, very difficult, as you can imagine, to control something like this. Very, very difficult. But we hope it's a way to kind of slow the spread of this thing. Now we put it into the realm where we have to start thinking, rather than eradication or annihilation of isolated populations, into what we call management of the existing populations. And with any system that I work with, I don't care if it's a greenhouse, I don't care if it's somebody's backyard, I don't care if it's a 500-acre plant nursery or the city of Gaithersburg. The approach we always take on this is what we call integrated pest management. In other words, we're going to use the very best mix of all possible tactics to try to reduce those populations to a manageable or tolerable level. In some cases, we may be able to eradicate insects. It happens periodically. We've done it from time to time with pests like the Asian longhorn beetle in Chicago and New York City. Other pests like Drosophylids on the West Coast. So it can be done, but I'm afraid for this particular pest, it's unlikely. So now we're going to turn to things like cultural plant management. How can we manage plants to be more resilient? Resistant plant varieties are in some of our pests, like boxwood leaf miner. We can simply plant boxwoods that are resistant to that pest. Can we do the same for lanternfly? Mechanical intervention. Can we squash lanternflies? Can we scrape their eggs off trees? Can we prune them out? Mechanical control, biological control, the use of predators, parasites, and pathogens to reduce pest populations. Mother Nature's solution. This is part of her hit squad that helps put a beat down on all kinds of pests. And finally, our last choice, Sometimes it's our only choice, but our last choice are going to be insecticides and miticides. We always try to do these things first before we resort to these. That's our game plan when we put together a management program. Now, plant culture. There's a fairly common belief, certainly in the industry, but also in the lay public, that somehow when we fertilize plants, that plants somehow become more resistant to insects. I hear this over and over again. And I was asked to give a talk at Kew Gardens or somewhere about this concept, and I did a little digging. I thought I knew the answer, a simple answer. Sure, that makes sense. No, it doesn't. It doesn't make sense. The data does not bear this out. So if we look at a large number of studies, 85, 71, 21, 9, this blue bar says when we fertilize a plant, particularly with nitrogen fertilization, the bugs are going to have a positive response. They're going to grow faster, lay more eggs, and develop quicker. Chewing insects, mites, gall makers, very few will be negatively impacted by additional fertilization. Okay, same for the chewers, the caterpillars, spider mites, and galls. Some of them will be variable. Sometimes they benefit, sometimes not, and others will have no response. So this is what I'm recommending is for people that have woody plants, if they're using high rates of nitrogen fertilization, to certainly back off of that. Woody plants are very conservative. They're very stingy in their nitrogen use. Remember, trees grow in a forest. They're not receiving 1 pound of fertilizer per 100 square feet. They're simply recycling their own leaves. They're very, very conservative. They know how to do this. So for the most part, for our woody plants and our perennials, we should really be backing off, because for these sucking insects in particular, when we fertilize, the nitrogen's going right through that plant into the lanternfly, and they're going to lay more eggs and say, thanks a lot. That's just what we need. So let's back off our fertilizers as much as possible. Can we find resistant host plants? Oh boy, this doesn't look good. Maples, birch, walnut, magnolia, tulip tree, locust, mulberry, sycamore, lilac, apple, cherry, peach, avodia, poplar, willow, styrax, alcova, Virginia creeper. Two of my favorites, hops, that's beer, grapes, that's wine. No good. And of course, the thing they love the most is what Betty Smith wrote about tree of heaven. This is one of the key plants that they depend on for reproduction. When I'm looking for spotted lanternfly, the first tree I look at is tree of heaven. Another list that was created: maple, beech, oak, tulip poplar, sycamores, ailanthus, more maples, syringa, birches, salix, poplars, alcovas. A list compiled by Tony Saminsky up at UMass, some of our most favorite shade trees and street trees: beeches, linden, sycamore, aspens, birch, cherry, gum, walnut, dogwood, snowbells, maple oak, paper birch, hickory, sassafras, serviceberry, tulip poplar, white ash willow. So the search for a resistant plant, out of this menu of things, there will be things they are less common on. Conifers, for example. Okay, so many of our gymnosperms may be resistant to these things, but in terms of finding resistant varieties or cultivars, I'm not optimistic at this stage of the game, because this palette includes many of the plants we use in our urban plantings. In addition to this, we now know that the immature stages will feed on roses, they'll feed on perennials, they'll feed on annuals, they feed on a lot of different plants. Okay. Mechanical controls. We could scrape the eggs. Okay, you can scrape the eggs off of the plants this time of year. However, I will tell you that I was up in Lancaster, Pennsylvania, looking at egg masses on trees. I can probably reach up to about 7.5 or 8 feet, something like that, and scrape all the egg masses. But beyond 8 feet, I easily counted more than 250 egg masses beyond my reach. So this could be a palliative. I guess if you just had a few lanternflies moving in, this might be useful. But this is not a management technique that's going to help us reduce the populations of lanternflies once they become established, because so many of them are simply laid high in the trees and out of our reach. Okay. Banding. There have been a variety of bands and traps. The spotted lanternflies, as I said, will lay their eggs on rocks and lawn furniture, and they'll then climb up the boles of trees to feed. So you can interrupt some of these with a band and catch some. And there have been very clever trap designs around the base of the tree that will capture lanternflies as they move around the landscape and kill some. But eventually these bands will become so thick with the bodies of other lanternflies, they simply march across. So again, this might be useful in low density populations, but it probably can't be used as an effective tool because so many of these lanternflies are on trees in the forest in unmanaged areas along roadways and railroads. That can we really lower the populations? And that's I think our ultimate goal. The good news. I don't have pictures of these things eating spotted lanternflies, but we absolutely know spiders, several species of praying mantises, the wheel bug, other assassin bugs. I think I heard there's a student now at Penn State and they've recorded scores and scores and dozens of vertebrates and invertebrates that have now turned over and have joined the hunt for spotted lanternflies. Part of the reason that this guy down here, the brown marmorated stink bug, has kind of sunk here in the east. Remember 15 years ago when you had a dozen of these things on your window or 100 of them up in the attic? Where did they go? They went down the gullets of the indigenous natural enemies, the predators and parasites that are here already. And I think we're hoping that these rascals are going to play a very important role in reducing the populations of spotted lanternflies. We call these numerical responses. Basically, if you remember back to your ecology courses, prey populations go up, predator populations go up. So we clearly saw with the brown marmorated stink bug that once that got going, wheel bug populations went up, spider populations went up, mantis populations went up. I've been out looking in several places now. I've never seen so many praying mantis egg cases on trees before that I saw this year. They're laying their eggs right within those patches where there are spotted lanternfly egg masses. So next spring, when the spotted lanternflies hatch, the praying mantises are going to hatch and have a feast. So there's some good news on Mother Nature's part. A tiny parasitic wasp called O. incertus that we imported back in 1908 to kill the eggs of gypsy moth. Guess what? It's developed a taste for spotted lanternfly eggs. So we're now finding this particular parasite emerging from eggs of spotted lanternfly. The scientists at USDA already have parasitic wasps in quarantine that they're evaluating right now, hopefully to be able to release in just a few years, that will attack the spotted lanternfly. We call this classical biological control, where we go back to the range where that pest is, we find out what's killing it there, we import it, we check it out to make sure it's not going to kill a beneficial insect or an innocuous insect here. And if it clears, then it's released and helps reduce that pest population. We reunite two old enemies. Here's the really good news. Outside of Reading, Pennsylvania, in autumn of 2018, there was a forested place near an apple orchard, we saw a massive die-off of spotted lanternfly. They look like this. There were 2 indigenous fungi, Batcoa and Bavaria bassiana. Now, Bavaria bassiana is a common soil pathogen. We use it all the time in greenhouses to control aphids. Guess what? They ganged up on spotted lanternfly and collapsed the population. The other good news here is we already have Bavaria labeled for use against sucking insect. There's another one called Iceria, another fungus. In laboratory trials, they were highly successful in greenhouses, 90% mortality, and in the field, 40%. So I think this collection, like I say, Mother Nature's hit squad of vertebrates, invertebrates, predators, parasites, and pathogens are all now beginning to work to put that beat down on spotted lanternfly. Let's go now to insecticidal control. Some research I found that was conducted over in Korea found that some of our synthetic pyrethroids, very potent chemicals, organophosphates, were relatively effective against the nymphal stages. Some of our systemic insecticides, the neonicotinoids, imidacloprid and clothianidin, were giving 100% control. However, some more interesting news, things like pyrethrum. Now, pyrethrum is on what we call the organic list of products that can be used in organic food production. Please understand that when you go to Whole Foods and you buy organic broccoli, it doesn't mean it wasn't treated with an insecticide to control the pests. It means if there were pests, they used a product that was listed by the Organic Materials Review Institute, or OMRI. This is an independent organization that evaluates insecticides that can be used legally in organic food production. And guess what? Pyrethrum is one of those materials, as is neem. All right, so now we've got 2 materials that are labeled for use in organic food production that can be highly effective in killing spotted lanternfly. So for homeowners, you can buy these as RTUs, ready-to-use products in your garden store. You can find pyrethrum or neem oil or neem extracts. All right, let's look at some of the really nice data coming out of Penn State now. They're the leaders in doing this research because they've been at it so long. Look, here are your synthetic pyrethroids, your dinotefuran, your imidacloprid. However, we know these neonicotinoids can be highly disruptive to bees, right? This is what all the fervor was about many years ago with our honeybees. So these are going to have very limited use in our landscapes because we're not going to want to be applying these materials in cases where they might interfere with our bees or other pollinators, right? Or natural enemies that are feeding on nectar and pollen. Having said that, they're going to give us excellent immediate control and excellent residual control. So on plants that they can be used on, they're going to be very effective in controlling the lanternfly. Here's a longer list. Now, this is an interesting list because not only does it include active ingredients that are used in the industry. The guys I work with are arborists and landscapers. These are some of the tools. I call them the sledgehammers of insecticides. These are the synthetic pyrethroids. Pyrethrum is a wonderful insecticide. It's derived from chrysanthemums, right? The problem with pyrethrum, both the good and the bad here, it has a very short residual. It breaks down in sunlight rapidly. So when we treat a plant with pyrethrum, it's very lethal to the things it contacts. But if a ladybug walks by a week later, it's not going to be harmed. The synthetic pyrethroids, things like bifenthrin, cyfluthrin, cypermethrin, these have been stabilized and they're highly residual. So if I have a very nasty pest like granulate ambrosia beetle or emerald ash borer, Asian longhorn beetle. I can treat the bark of my tree and I can kill those borers that are trying to bore in for up to 3 weeks. That's the good side, but the downside is if a ladybug or a lacewing larva walks by a week later, it could be killed by the residue. So these are the sledgehammers. They're going to give us excellent control, both initially and then as a residual, several of them. Carbaryl is 7. This is an insecticide you might use in your garden. Excellent initial knockdown. But the ones I really want to talk about here are these guys. Here's your natural pyrethrin again, giving us excellent contact. So if we see little nymphs of spotted lanternflies or adults, this is going to give us good control, but very little residual. So when you see those guys, if you squirt them with your natural pyrethrins or your neem oils, you're going to get good, excellent or good immediate control, but very little residual. Even insecticidal soaps, some of our botanical, our horticultural spray oils, good controls. Okay, so we will have tools we can use against these spotted lanternflies. This is a nice chart. I was at a meeting on Monday, and the clever crew up at Penn State put together this very nice decision matrix. I'm going to walk you through it. Suppose we have severity, in other words, the densities of spotted lanternfly ranging from low to high, intolerable. Occasional egg masses, a few egg masses, many egg masses, and feeding stages, heavy levels of adults, sooty mold. Okay, everybody got that. Down this axis, we have the likelihood of impact. Is it a favorite tree? Are there many on the favorite plants? Are the plants under stress, which is not going to be good for the plants either? Or are they proximate to vulnerable plants, vineyards in particular? Okay, likelihood. So if we have plants that spotted lanternflies really do well on, like maple trees or tree of heaven, and we have highly dense populations, now we've got a high risk. The antithesis would be if we have just a couple lanternflies flying around or a few egg masses, and it's on your favorite tree, but at very low densities, we have a low risk of an economic impact. So let's jump ahead now to the economic impact table. At the very lowest level, again, this green area, we can do things like cut down on our fertilizer. We can remove the favored hosts, in this case, tree of heaven, things like that. We also need to assume that if we see damage, it may be of other causes, not necessarily from spotted lanternfly. If we start to move into the yellow zone, we can try to scrape. We have a few lanternflies. We can try to scrape egg masses or kill those things. Retribution, squash them, flatten them, right? Stomp them, whatever you want to do. Hopefully, we'll move into an area where our natural enemies now are beginning to respond to those increasing levels of the prey population. They're starting to move in. So now our natural enemies are starting to take over. But what do our natural enemies need? What do hoverflies need? They need other resources. They need nectar and pollen. So now we have to have these other plants that help support our natural enemy community to provide an alternative food sources, nectar pollen sources, alternate prey. So now we're starting to manipulate our landscape. We're planting flowering trees and shrubs to increase the biodiversity, to increase that top-down pressure from predators and parasites, right? And in addition, we hope down the road, we'll actually be able to import some predators or parasites and release them. Right now, we really don't have any indication that buying ladybugs and releasing them, for example, is going to work. So we're not recommending that. Once we start to get to these higher densities, now we're moving into this zone here. Now we're going to probably try to switch over and use our neems, use our pyrethrums, use our botanical oils, use our least toxic. But if we're in a situation where we've got ailanthus trees or maple trees growing next to a vineyard, or we're in the vineyard itself, now we're probably going to have to fall back and really use some of the registered, EPA registered chemicals that we know are going to reduce those populations and be able to avoid the economic damage associated with the lanternfly populations. From January to May, we can destroy egg masses. We can put up sticky bands to try to interrupt the movement. Registered insecticides when we have nymphs and adults that are feeding. Avoid transporting things out of quarantine zones and moving those egg masses of the females, right? Removing tree of heaven, okay, could be important. In fact, a number of nurseries and a number of vineyards are now removing all those tree of heaven that are growing in hedgerows around those places that are supporting high populations of lanternflies. And this tactic I'll call trap trees. I'll show you what this means and how it works. But basically the theory here is you cut down all of the potential host trees in an area. You're not going to do this in your front yard, gang, or in your neighborhood. Don't misinterpret what I'm saying here. If you were a small woodlot owner, or if you had a vineyard and you had a small woodlot, what you could do is chop down all the host trees, treat a couple of the trees with these potent systemic insecticides, a tree that's not going to be attracting pollinators. The lanternflies will fly in, drink the Kool-Aid, commit suicide, and you'll reduce the population. This is the theory behind the trap tree method. Economics. Right now, Pennsylvania believes they're losing $50 million and about 500 jobs per year. If it's not contained, they expect that to grow to $320 million annually and about 3,000 jobs. And worst case scenario, the entire state, all grape growing regions, about half a billion dollars a year and 5,000 jobs. So these are projections I just saw this year coming out of Pennsylvania. And I think this is kind of the bellwether of what we might begin to be prepared for as this begins to spread and moves through our area. Okay. With that, I'm going to leave you with this thought, that I think ultimately our solution lies where it always does, with Mother Nature. I hope that some of you have watched these spectacular documentaries with David Attenborough, who basically is espousing the very same things I'm talking about here today. Let's create habitats that foster biodiversity, sustainability, because ultimately that's going to be the solution to these problems. So I think that's where we need to head. And on this rather somber note, the lanternfly and I wish you happy holidays, and I'll be happy to take any questions that you might have. I know I ran a little long. I thought I was going to finish it up quickly, but I got telling stories. So if anybody's still on, I'd be happy to answer some questions.
It's all good, Mike. Can you unshare? We'll come back together and we'll do questions.
Sure.
All right, let me just put a spotlight on you. All right, any questions for Mike? We have Chris says, can lanternflies have a utilization use? And why are they toxic?
Oh, well, you know, tree of heaven in and of itself has some really, really nasty secondary plant chemicals. And I'm guessing because of the heavy use of this in an evolutionary sense, that they simply sequester those compounds in their bodies, and hence the evolution of the aposematic coloration, that striking underwing pattern of red and black is clearly aposematic, a warning coloration that, hey, don't mess with me, I'm toxic. Now, as they feed on other hosts, we don't really know if that toxicity will be maintained. So we don't know what evolutionary trajectory these guys are on. But I believe that they're toxic by virtue of the plants they feed on, and that's probably why we don't want to mess around with that. Now, the other piece of the puzzle, sure, of course, once these things are annihilated, they can be composted just like anything else, any other pest, and recycled into the environment. This is always what I do with my stink bugs. Once they're frozen and dead in my freezer, I take them and add them to my compost bin, and they help feed all the creatures that are developing, my soldier fly larvae and beetle larvae that are developing in the compost. So sure, of course, they have that, like all things, they have that utility. That's where we're going to ultimately, right? Soylent
Hey,
Green.
I have a question. Yeah, and if you want to unmute and ask a question as well, just raise your hand and I'll call on you. But I have a question right now about, you showed the graph of the rate of invasive coming out. We've known about invasives for a long time and how they travel from place to place. Are there no controls put in place? Why couldn't they have sprayed some stones before they brought them over here to money? Okay.
Money makes the world go around. New Zealand actually has the very best service in terms of keeping invasive species out. They've got the best track record, but us, frankly, not so much. There are literally tens of thousands of containers that arrive in this country on a daily basis, and a very small proportion, I think it's less than 5%, are ever inspected. So, I've kind of fought this battle for 40 years. This is a battle that has to be won at the legislative level. It has to be done at a national level. It's not one, well, we can hopefully do it with our ballot. That would be the way to make these changes, of course. But again, it all translates back into money. This is heresy, I'm sure. But what would happen if we simply charged $1 for every container that entered this country to go into a huge fund? So when we bring the next emerald ash borer or Asian longhorn beetle or spotted lanternfly into the country, there's a pool of money to help reforest the native ash populations, the city street trees in Chicago and New York City, the tens of thousands of trees, or help our vineyard growers deal with this pest. I mean, well, I guess your computer chip that was built in China, they're going to add $10 if we charged them $1, right? So these are all economic decisions. These things certainly are soluble problems, but we would have to have the economic will to do this.
Well, I mean, something like just if I'm just thinking the boats could go through and all get irradiated in some form or fashion. It seems like there could be some kind of a mass anyway control.
Yeah. Or even the inspectors that inspect these things. I mean, the funds for inspections and things, a lot of these agencies struggle to find enough resources to even conduct. They do a wonderful job of it, but they're shorthanded as well. So, we've got to have an economic will to do this as a nation.
Well, the jobs that are lost in Pennsylvania through the lanternfly, those people can be hired to be inspectors, and that's a different job situation. Mike, on the same topic, since nobody else is asking any questions, I'll feel free. So it's about the vineyards, and has the lanternfly found its way to any other countries, or is it just from China to here? I know that you said the other Asian countries, but is it in Europe or anywhere else?
Not to my knowledge. I'd have to do, Bronwyn, I'd have to do a little more checking up on that. But I think the last time I perused the literature, those are the nations where it's invasive. And to my knowledge, not in Europe yet, but in other parts of Asia for sure. And again, this is probably, as Fred says, it's probably a matter of time. Yeah. So what we've done, what that graph shows, that's one of my favorite graphs. Basically, what this is demonstrating is a global economy. And a global economy simply translates into a global biota sooner or later, right? As we move things around this planet, we've simply accelerated the rate at which natural events happen. I mean, things move, they move on birds. Scale insects hook onto the feet of birds and are transported hundreds of miles. Things become aerial plankton. The Hawaiian Islands were colonized by things that drifted from continents and landed on their shores. So these are natural phenomenon. It's just that we've accelerated the rate at which these things can happen. So, you know, it's going to be, we're conducting a very interesting global experiment right now on several levels. Certainly the climate is one. The movement of creatures around this planet is another very interesting experiment we're conducting right now.
So so we're just speeding up a natural process. So at some point, equilibrium will be
Oh
met.
yeah. Oh yeah, yeah. Mother Nature has a way of taking care of these things. You know, there's certainly, you know, when the comet hit the Gulf of Mexico 65 million years ago, it rearranged things quite dramatically, and it created a lot of habitat for new things to evolve. So yeah, nature will solve our problems sooner or later. We're not going to be here to witness it, but nature will find a way to solve problems we create. There's no doubt in my mind that's the case.
Do you suggest that when you see the lanternflies, we should kill them in our yards, and if we're hiking, just go ahead? I mean, is it?
Yeah, if it makes you feel good. Yeah, if it makes you happy, you know, it can't be all bad. I don't know. It's kind of retribution. I'm not going to do it. You know, when I was in rocks, I could have spent 3 days squashing lanternflies, and I just didn't have that kind of time. So I'm not saying don't do it. And certainly the first lanternfly that shows up, the gravid female that makes her way to your yard, you could squash her. That'll slow things down a little bit, but it has to be that comprehensive program I talked about before. And it's got to happen at a bigger level than the individual level. They tried this in Pennsylvania. The initial response in Pennsylvania was to encourage, you know, homeowners, citizens groups to find lanternflies, to kill lanternflies, to scrape egg masses. And you can see in less than a decade, you know, what the result of that was. We simply can't go out. You know, as I travel Route 78 back and forth to Jersey, I stop at a couple of the rest areas, the truck stops, and here are semis. There are half dozen semis that have been parked there for 2 weeks. And I climb over to that bank, you know, where the oil cans and the debris are, hop over the berm, and there's the ailanthus. And there are thousands of lanternflies right there. And they're just going to fly over to that semi and lay their eggs on the tire or the side of the truck. And it's going out to Utah. So this has to be managed on an area-wide basis in a very comprehensive way. And I think our ultimate solution is for our guys that are at the greatest risk, our grape growers. We've got to find ways to manage those lanternflies in those vineyards and hops and our high quality crops. And then we've got to get that right mix of natural enemies into landscapes, increase the biodiversity. So we have that top-down pressure from our predators and parasites, and increase discoveries like those 2 fungi that just popped up out of nowhere. We can commercially formulate those things and have a very nice kind of an organic or natural approach to managing these things with an intervention and application of a fungal disease that's going to kill these things. So it's going to be a multifaceted approach that's going to depend on a lot of things. But if it makes people feel good to kill these things, then, you know, I'm certainly not going to tell you don't do that. All right. I think everybody's entitled to make their own decision on that one.
Fred has his hand up. Fred?
Hey, Fred.
Hi, Mike. How are you?
I'm good. Happy holidays.
Thank you. Same to you.
Yeah.
Excellent talk. Appreciate this a lot. I had a couple questions. Um, the fungal control, is there a risk of non-target species with that kind of use? I just wondered.
Yeah, well, it's a great question. Fred, we've been using Bavaria for at least 20 years in greenhouses and landscapes. It's indigenous. It's down there in the soil. I mean, that koa was a new one to me. I'd never heard of it. The Bavaria we find all over the place with regularity. So again, these are indigenous things, Fred, that are just out there hanging out, taking advantage. And when you have a super abundant resource, right? That's what the spotted lanternfly is and was out there. Super abundant resource. Boom, they hit it. And just took it out. We see the same thing, of course. The other analogy, of course, is the entomophaga, which we release to control gypsy moth. This has done a spectacular job of reducing gypsy moth populations. It's now part of our natural ecosystems. When gypsy moths start to rise, it goes up, it takes the gypsy moth down. So this one is native, they're natural, they're naturally occurring. So I'm not particularly disturbed about this. The other one, the Asaria, that's already formulated for controlling insects. I think it's great that we have these fungal tools, and they are rather specific. I mean, these are not necessarily things that are gonna, they're not gonna spill over to birds or other creatures. These are things that are going to be zoned in on various kinds of insects. So I think this is all very positive. And again, on the cost benefit side, I think your benefits are really high and your potential costs are very low at this stage of the game in pursuing this particular avenue for biological control. Good question, though.
Oh, well, thanks. Yeah, I just wondered about that. I know the Chinese had used some fungal control for cerambycid beetles, and they would shoot them out out of some sort of projectile over the forest. And I'm not sure what that one was, but they seem to be using it a lot. So
yeah, that's
anyway.
cool. Was that for lanternfly or was that for another kind of pest?
I think it was for beetles back when.
Oh,
it was a while ago.
That could be. That could be. Yeah, they've done a lot of things. They basically pioneered a lot of the work with using the entomopathogenic nematodes for controlling clear-wing borers and beetles. Yeah. Yep.
The damage to the grapes, how severe is that?
Extirpated 2 vineyards is what I heard. I was at a meeting, I think a year or so ago, and 2 vineyards killed, like killed, dead, gone out of business, finished, boom. So to me, that's pretty dramatic. I think, it's dying by 1,000 knife stabs. I mean, when you've got, I don't have the image up anymore, but when you've got literally thousands of beaks plugged into your phloem tissue, there's enormous tissue damage. They're removing fantastic quantities. You saw that honeydew coming out of those things. It's remarkable.
Yeah.
They're pumping away honeydew like crazy. I think they just starve the vines or cause so much mechanical disruption of the vascular elements that the vine simply couldn't recover. So that was the scare story I heard up in a meeting in Penn State, that 2 vineyards had been destroyed, totally destroyed by these things.
The same thing happens with the fruits, cherries and blueberries and that sort of thing?
Not so much. No. That's why I'm saying we have to kind of back down, because as I said, I don't have a confirmed account. I have not seen data that they've killed a blueberry, killed an apple tree, killed a shade tree. I mean, I've seen tremendous densities of these things, tens of thousands you saw that screen where I panned down those ailanthus trees, and there are thousands of these things. Same thing. Those trees are surviving. So trees, for whatever reason, it's not going to be a tree killer. Early on, we had some early releases, unfortunately, some by my colleagues, that said they're going to kill shade trees and forest trees and things like that. And that just has not panned out. It hasn't panned out. So this is not going to be a tree killer in a home landscape, to my knowledge. This is going to be a nuisance when, you know, you're having a party and you and the aunts and uncles and grandma are sitting under a maple tree and it's simply raining down honeydew on the on the picnic. Actually, the reporter said, you know, well, we should just get our Cheerios and stand under the trees and they'd have the sugar on them already when we ate them. So she thought it was kind of funny, but not everybody's gonna appreciate that. For me, it's just cool, but for a lot of people, this will be disturbing.
Yeah.
Yeah.
So Joanne asks, are the native grapes also at risk?
I would think so, Joanne. I have not heard tales yet of fox grapes and our other native grapes, but I don't see any reason why not. I can't imagine, because, you know, Joanne, that host list was so big, right? That host list was so big that I got to believe that they're going to be able to take any kind of vitus, I think. So I'm guessing that our native grapes are probably at risk as well. Yeah.
All right, any other questions for the bug guy in 2021? You got him here. If not, you have his email. Make sure that you plug in to the Bug of the Week blog and the YouTube channel. I also put up there in the chat our YouTube channel. Please subscribe when you go to both of them. It helps a lot. And I agree, Jennifer, this was great. It's always wonderful to have Dr. Raupp share his knowledge and expertise and talk bug stories, insect stories with us. So be on the lookout. Oh, one question: Are they asking citizens to submit data when they see them? Is there some way that we should do that?
That's a great point, Bronwyn. I think if you're not, I think we're not asking for any more reports out of Cecil and Hartford. We're well aware that. I should have made that point. Yeah, if you see egg masses, I think I've shown you all the life stages. Again, you can go to Bug of the Week and the YouTube Bug of the Week and refresh yourself on what the different life stages look like. Certainly next spring, if you see the nymphs or adults, please call the Maryland Department of Agriculture and report this, especially in our counties like Montgomery and some of the counties where we haven't seen them yet. And even in places like Howard, I've spent a lot of time running around Howard and Frederick looking for these things and found, you know, very isolated low levels. But it would be very helpful to report those to the Maryland Department of Agriculture, or you can report them to your county extension office. Every county has a county extension office. It's part of the University of Maryland. You can find those numbers in your phone book or by doing a Google search. So if you see the spotted lanternflies, please do report them. We're still trying to track them. We'd like to know where they are, so when the time comes for interventions, whether it's releasing parasites or just trying to determine what's at risk, informing our grape growers that, hey, you know, we found spotted lanternflies 5 miles away, get ready. You know, this kind of information is extremely valuable. So when you find them, please do report it. That would be great. Thanks, Bronwyn. Great point.
Are you hooked into iNaturalist? I know a lot of folks here use iNaturalist. They can use that.
Absolutely. Yep. Sure. You can do the iNaturalist thing. That's great. And you can you can always send images. If I've had several, as you might guess, images sent to me of perhaps spotted lanternflies. So if you shoot those over, I promise I will try to get to them as best I can. Sometimes it might take a week or more, but if you see something you think is a spotted lanternfly, by all means, you can share it with me or shoot it over to Maryland Department of Agriculture. I think they've actually got a website set up where you can click on and make a report. So that'd be great. Thank you.
Wonderful. So everybody, thanks again for joining us and exercising, coming to this gymnasium for the mind that we have and exercising your curiosity muscle. Now you take that knowledge and go share it with other people and make the world a little bit smarter. We'd appreciate that. And hopefully we'll see you on Saturday to go and see how we can get our eyes up into space and try to find some more planets out there. And then our last Thursday, our last Must Learn Thursday of 2021, we're going to learn about some rattlesnakes and what's going on with them. So thank you all. Stay well, stay curious, and we'll see you soon.
Thanks, gang. Have a happy holiday. I look forward to some face-to-face meetings with you guys down the road.
Thanks.